2 times 10 to the negative 8. So, exponent is negative. According to the rule, that means I have to go to the left. 8 times to the left. So the decimal starts there. 1. The rest of these are going to be empty hoops. 2, 3, 4, 5, 6, 7, 8. I have 7 empty hoops. And there you go. Okay. Last thing we have to do today, this is the new thing, it's not difficult, it's just something new, is multiplying in scientific notation. Now you can see at the top of that column, I've given you instructions for how to multiply in scientific notation. And it really is as easy as it sounds. We're simply going to rearrange the problems. We're going to group the numbers and the powers together. We'll multiply those, and then we'll recombine. Okay, and obviously your answer will be greater than scientific notation. Again, you're going to rearrange the problems, grouping the numbers and the powers together. Multiply. After you multiply, recombine, and then write the answer in scientific notation. This is easy. Look at example 8. 2.7 times 10 to the 4th, 6.1 times 10 to the 2nd. 2.7 times 10 to the 4th, 6.1 times 10 to the 2nd. Okay. Step 1, you're going to put the logical things together. So what I'm going to do is I'm just going to flip those two inside things. Now look what happens when I do that. I've got 2.7 times 6.1 and 10 to the 4th times 10 to the 2nd. All I did was I flipped them. That's the commutative property of multiplication. Says I can change the order around. It doesn't affect my problem. It doesn't. All right. Now, 2.7 times 6.1. That's no big deal. Okay, that's just a plain old multiplication problem. You can multiply that. You can use a calculator, whatever. So 2.7 times 6.1. That's 16.47. Now, 10 to the 4th times 10 to the 2nd, you know how to do that. Got two powers, both have 10s. If I'm multiplying powers, what do I do to the exponents? We add them. So 10 to the 4th and 10 to the 2nd is going to make 10 to the 6. There you go. Now, this is pretty close to done. There's only one little teeny tiny thing wrong with this one. It won't happen in all of them. Is that, remember, scientific notation, the decimal has to come after the first number that's not a 0. So technically, the decimal should be between the 1 and the 6. Okay. If you run into that, simple thing to fix. Move the decimal 1 over. 1.647. And increase this exponent by 1. Times 10 to the 7. There you go. If you had to move the decimal the other way, you'd knock the exponent down 1. It's the same rules that we did over there. All right, so the last one. 1.25 times 10 to the 6th, 7.6 times 10 to the 12th. 1.25 times 10 to the 6th, 7.6 times 10 to the 12th. Again, switch those two inside terms. So I'm going to put 1.25 and 7.6 together. And I'm going to put 10 to the 6th and 10 to the 12th together. All right. 1.25 times 7.6 is 9.5, so we don't have to make a change here. That's good. Okay, 10 to the 6th and 10 to the 12th.
10 to the 18th.
There you go. Booyah.